We're going to talk about means and altitudes. First thing we're talking about here is medians. Medians, by definition, are a segment from the vertex to the midpoint of the opposite side of a triangle. As you can see, it goes from the vertex to a vertex of a triangle to the midpoint. That segment created is called a median. Now, since it goes to the midpoint, what do we know about what does it do to this side? It what? It goes to the midpoint, so it bisects it, cuts it in half. So we know that this has to be congruent to this. Okay, this is an important, you need to know what a median is. Put that up, please, Kagan. Any questions on what a median is? Does that confuse anybody, or is that a pretty simple concept for us to grasp? It is something you need to know. I expect you to be able to sit around at parties and talk about what a median is, so know what one is. I'm sure that's a topic of conversation. Now, next thing we're going to talk about in this section is called an altitude. It is not quite as, well, it's used more than a median in everyday life. What does this triangle look like that you think of an altitude of? Anybody ever been to the Rocky Mountains? Does this not look like the top there, look like the peak of that mountain? And the altitude measures how high that is. How do we measure that height? Straight down. In other words, in a right angle. So as you can see, an altitude is a segment from the vertex of a triangle that is perpendicular to the opposite side. It basically tells how high that point is. If that was a plane up there, wouldn't I be, and this was the ground, wouldn't I be, this segment tell how high that plane was flying? Agreed? Anytime we find the distance from a point to a line, we do it along a right angle. So that is why that is called the altitude. I have no idea why it does that. Any questions on altitude? Any confusion there? Okay. Here is the main point of this section, the thing that you will use the most. How many medians do you think there are in a triangle? What is the definition of a median? Goes from a vertex to the midpoint of the opposite side. So how many vertexes are there? How many sides are there? So how many medians are there? 3. As you can see, there's a little mark right there. That's probably to mark the midpoint. And, oh, real quick, guys, hold up before you start writing this down. I put a picture of this on Canvas because it is, you know how I've talked about how these are hard to write down. I'd rather you listen to me than write this down. I'd like you to take the picture from Canvas and draw it in your notes eventually, but right now I don't want you drawing. I want you listening. Because this is very easy once you get it, but it can be hard. That would be a median. And what would that median do? Cut that side in what? Into halves. Well, I have another mark there that's probably indicating where the what? Midpoint of this side is. That is a median. So what does it do to this opposite side? It cuts it in. So this would be congruent to this, correct? Now, why do you think I didn't draw the third tick mark? Little marking, you know. Why did I not need to draw that? Why do I not need it? I need to draw the third median. Why do you think I thought I don't need to measure and see where the middle of the third side is? What did we learn about last chapter? We had what? Or last section we had a bunch of points of concurrency, didn't we? I bet that when I connect the dots right there, I bet I land at the midpoint of that other side. Does it look like it? Sure does, doesn't it? And it turns out that the medians are points of concurrency. They do create a point of concurrency called the centroid. And you do need to write this down. The centroid is the point of concurrency of the medians of a triangle. Now something very interesting happens, and I teach this a little different than the book does. The book uses fractions, okay? And yes, we need to understand that, but I think this is the easiest way to understand this. There is a special relationship between the parts the centroid makes. And what do I mean by that? This centroid, this green, let's look at the green one. It cuts it into two parts, doesn't it?
Yeah.
It turns out, if this bottom part was x, you know what the top part is? It's 2x. So what would that make the whole green line then be? Green segment, I mean. Very good. Now here's the way the book describes it. Someone read to me the definition, what they say about a centroid. I think you'll see the word 2/3 somewhere. I tell you, turn to the last page of the section. Of that section. To the last page, there's a chart there.
It says that it is 2/3 of the distance from each vertex to the midpoint of the opposite side.
That this centroid is 2/3 from the vertex to the vertex right here. So what they say is that this is 2/3 of the whole distance, and this is 1/3 of that distance. And that is correct. Because this is 1x, and this is how many x's? The whole thing is how many? So this is 1/3, this is what? 2/3. But which is easier to understand, x and 2x or 1/3 and 2/3? X and 2x. Now, if they ever just give us the whole, if they said the whole thing was 9, how am I going to find out what these parts are? Anybody want to guess? They said the whole thing is 9. Well, the whole thing is this green thing, right? So 9 would equal what? Don't write this down. 3x, correct? Well, I could find x then, couldn't I? What would I do? So x would be what? So this would be 3, and what would that make this? 6? Because it's always double what the smaller part is, correct? And the smaller part, you'll be able to tell, because they kind of have to draw these to scale, but it's always to the midpoint. The larger part's always to the what? Vertex. But how I like everyone to think about this and I think it helps because you can put it into that formula any way, shape, or form. Let's look at this part. Now this is a different length, but let's say if this was y, what do you think the bigger part is? For the orange one. If this is z, what's the bigger part? 2z, not 3z. Goofball. 2z. So, look what happens here. The blue line. All right, we don't have a blue, do we? Purple is what? 3 what? And the orange is what? 3z, right? So no matter how you do it, it's always 3 times the smaller one, isn't it? The whole thing. So if they give you the whole thing, you can always just divide it by 3, find the smaller one, which will then lead you to what? The other piece, right? If they ever give you this one, how does this one relate to this one? How does z relate to 2 z's? Isn't that half of it? Remember, this one was 6, this one was what? 3. What do you think if this one's 10? What's this smaller one going to be? 5. If this whole thing is 24, that's 8, isn't it? Divided by 3. And that one's what? 16. So you see how you can find any of these if they just give you one of those quantities? The picture I have on Canvas is a little bit cleaner than that because I didn't goof up and make that mistake. But that's the big deal. That's the bulk of this section, is understanding the relationship between the parts created by the centroid of each median. The other thing you'll have in this section, which, to be honest, isn't as big a deal, what do you think all the altitudes do, if you were guessing? Do you think they might meet at a certain place? They do. However, there is nothing special about that place except that they all meet at that place. You don't have to write this down. All you got to write down is the orthocenter is the point of concurrency of the altitudes of a triangle. Just need to write that vocabulary down. But it turns out there's no special relationship between the pieces created or anything like that. However, there are some right triangles created there. So that's probably how they're going to give you problems with this. They might give you 2 of the 3 sides here, and you're going to have to use what theorem? Pythagorean's theorem to find the third side. But the 3 altitudes meet in what's called the orthocenter. Don't ask me how they got that word. That's what Google's for. All right? Now, once you're done with that, get out your red books because we'll do some examples towards these. Everybody good there? Okay. They say that this is a centroid. Well, how do they say it, though? How do I know this is a centroid? What do each of these segments do? They go from the vertex to the what? Vertex to, vertex to. So they don't have to use the word centroid. This is where you have to look back in the book, okay, which one's the one that has a special relationship? You look up, you find that it's centroid where the medians meet. So right now, before I even look at anything else, you know if this is X, what's this? If this is Y, what's this? If this is Z, what's this? So, oh look, they already gave me this one. If this one's 4, what's this one then? Or how did I do this? Well, wait a second. How did I do this wrong? I made a big mistake there. Can anybody tell me? I just started spouting out nut letters.
Because you said
I said the bigger part was x and this was 2x, right? You got to pay attention to that. It's real easy to come up here and look at this and just want to start spouting out x, 2x. You got to make sure, because, you know, this one's kind of small. I guess when I zoom in and it becomes real big up there, isn't it kind of obvious that this is the smaller one? But look at it for a second and make sure you get it right. Don't do what I just did. If this is x, then this is what? Because this is the longer, isn't it? If this is y, this is what? If this is z, this is what? Now, I can start replacing some of these this is the bigger, right? So what would the smaller be? If this is 4, what's this got to be? Huh? 2. Makes sense, doesn't it? Well, is this the bigger or the smaller of the two? Bigger. Well, how does the smaller piece relate? It's what of it? Half of it? So if this is 3, this is what? 1.5. Now, for me to find these two, they must have given me some more information. Let's look and make sure they did. What else did they say? They said that NQ, this whole thing here, was what? Ah, that's what's supposed to help me find those pieces, isn't it? Well, how do I find these pieces? Well, I know NQ is 6, but I also know that it's 3 times x, isn't it? Or whatever you want to call it. You want to call it y, p, it doesn't make a difference. Basically, you know you have to divide that by what? 3 to find out what your smaller piece is. What is your smaller piece? Making this. Glance over there at those other ones. Have I answered every question they asked for there on 1 through 6? K to M. Did I answer that? 2. K to Q. Did I answer that? 4. L to K. Did I answer that? 1.5. L to R. Didn't answer that, but can I easily get it? L to R. What would it be? 4.5. I added 1.5 and 3. N to K. What is that? 2. P to M. I didn't answer that, but what is 4 plus 2? So you see how easy this can be once you get it? The problem is it can be a little confusing, especially the one everybody has problems with is when they give you the whole thing. Because now I have to realize that I need to divide. It's not just cutting it in half or doubling it. Okay? You got to see what 1/3 is so you can see what 2/3 is. Any questions there? Look at this one. They tell us that H is the centroid. They tell us that S to M is 24. They tell us that D to H is what? 4. And they tell us that E to H is what? Okay, one piece at a time, one median at a time. With this median, do I know the smaller or the larger? All eyes up here. I'll let you write this down. Do I know the smaller or the larger? So what's to make the larger? What do I have to do to the smaller? Double it. So what does it make this? Look at this median. Is this the smaller or the larger? So what's the larger? I have to double it. Here, do I know the smaller or the larger? No, I know the what? Whole thing. So I need to take the whole thing and divide by what? 3. What do you get? 8. So that means this smaller part, which one's the smaller part? Tell me. Is what? And what does that make the larger part? So have I answered everything probably that they want me to here, or at least made it to where all I have to do is add them up? Probably. So as you can see, this is pretty easy, isn't it? And you guys may need to trace some, you know, like if you're, or I mean, it's really, these aren't as hard as what yesterday's were to draw. But I still expect you to draw the figures and do a decent job with them. They don't have to be works of art. Like I said, trace and go dot, 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 dot. Shh, shh, shh. Then you make it, right? then you label it. You okay over there?
Yeah, it's terrible.
Seem like you were growling. All right. Your assignment, which is due. Pay attention to this, end of the hour, tomorrow. Is numbers 1, 2, 5 through 10, 16 through 25. Write problems, draw figures, show all steps, and work. Now, I want to show you something on Canvas right quick, and you'll find this helpful. And I probably should do this more. But on today's assignment, I click on today's assignment. It's got your assignment there, but I also took a screenshot of that, which is how a centroid relates, right? So if you're sitting there doing your homework, you could just hold that in your phone right beside you, couldn't you? You also got, I went ahead and took a screenshot. Does anybody recognize that chart? And I said, add this chart to your notes. This is a really good chart. I'm going to zoom in on it. This chart in the book says, okay, it connects 5-1 and 5-2. Perpendicular bisector tells what it is. It's perpendicular, cuts it in half. The point of concurrency is called what? Circumcenter. And then it says special property. The circumcenter P of triangle ABC is equidistant from each vertex, and then it shows a picture of it. And it goes through that for all four of them, doesn't it? And if you'll notice, there really isn't a special property for the altitudes other than they have a point of concurrency. And we named it something. So this is something that'd be good to pull up when you're doing your homework to help remind you of each situation. Agree? Okay, so you've got that. If it were me, I'd make it your screenshot, on your phone, make it your background. Wouldn't that help you? All kidding aside.